Hey there, folks. Let me get this out to the full screen here. We have one last problem to work actually in 3.4, and that is 16C. So let's take a quick look at that. It's not too bad. We've actually done the A and B parts of this problem. Now they're going through and they're saying, all right, let's do let's take a look at this. They've been telling us what f could be, and then asking us to find solutions. So, and we've actually, I think, already done this, a couple of parts of this problem. But let's take a look at it. It says, let B be this conglomeration right here. Find all pairs E and F such that 22 divides B. So, the thing we've got to really point out, and here's my, I don't know if it's a proof or not, but our solution. By our product theorem, uh, 22 will divide B if and only if 2 divides B and if 11 divides B. That's occurring since 2 times 11 is 22, and also the greatest common divisor between 2 and 11 is just 1. Or in other words, they're relatively prime. Okay? So, to get divisibility by 2, then this last digit has to come out of the set 0, 2, 4, 6, 8. In other words, the single digits that are divisible by 2. Okay. Then for 11, we need to take a look at where we add up the odd position digits and then subtract the sum of the even digits. So let K be the following. We'll add up the F and then the 4 and then the 5 and then the 7 and then the 1. And we'll subtract the sum of the others. 2 plus E plus 6 plus E. So this is, let's see what we've got here, 9, 16, 17 plus F minus, and here we've got 2E plus 8. That was an odd thing to have happen. Okay, I think we're still recording, best I can tell. I don't know what that was all about, but I guess it doesn't matter. So, all told here, we've got, this would be 17 minus 8, 9, plus F, minus 2E. We know that 11 will divide B if and only if 11 divides this K that we're talking about. Okay. So we look at the different cases here. If F equals 0, and actually, I'm sorry. Okay, sure it seemed like no time passed at all, but I put out 2 fires in the amount of time it took us to do that. Alright, so if F is 0, then, oh, and I'm sorry, I gotta get my Skype business. Let me just get out of Entourage altogether. My bad on that. Get Skype. I'm sorry, I forgot what all we were doing. Back to full screen. Here we go. Alright. So if f is 0, then since E can only be a single digit, so it's going to range between 0 and 9. So I should say then this happens. I'm actually not saying this very well, I'm sorry. And, that's an and, let me just mark it out and write it. And, that means that K is going to fall between, alright, it's going to be, we're subtracting E, so it's going to be at its smallest when we're taking F out of here, and then, and this is actually the A part, we've kind of worked it, but I'm going to work it again. So 9 minus 18 is a negative 9, and when it's 0, this would just be 9. Okay? Thus, K equals 0 is the only number that could possibly be divisible by 11 in this mess. Okay? But if you look at 9 plus 0 minus 2e equal to this, sorry. Okay, we're back. Sorry, this is real fun. Alright, so if you try to solve this for 0, this has no integer solutions. E. So we get no solution on that one. Alright, if f is equal to 2, then K is, it's probably easier to write these things out, 11 minus 2e, and we know K is going to have to fall between, again, at its biggest, or its smallest would be when E is 9. That's a minus 18, so that's a negative 7. And then if it's just 0, this is 11. We talked about how, in fact, every time, because these are going in chunks of 2 here each time, and we're taking away an even number, this is going to be odd every time, and this is going to be even. There's no way you're going to get a, it's going to have a factor of 2. There's not going to be any way at all we'll get a solution for K equals 0, I can tell you that. K equals 0, this is 11 minus 2e, has no integer solution, I should say. It does have a solution, integer solution for e. And if we let this 11 minus 2e equal 11, which is in the range now, then we have e equals 0. Has no integer solution, and this has solution e equals 0. So we have e is 0 and f is 2. That's one of our solutions that we actually pulled out of 12b. Alright, let's see if we get the rest of these real quick. If f is equal to 4, then k equals, and now this is 13 minus 2e, I'm going to skip a little of the writing here. This would go from, let's see, if I put in 4, that's, yeah, I got it here. And then with E being 9, that's a -5. And with 0, that's 13. Okay. We only have a solution with k equal to 11, which is 13 minus 2e. So take this over, e is going to be 1. Okay, so we have 1 for e and 4 for f. That's another solution for us. Okay. If f is equal to 6, then k is equal to, if we put 6 in here, that's 15 minus 2e, with k going from a -3 to 15. Oops. Okay. The 0 solution is in there. It's divisible by 11, but there's no way we can get an integer answer for that. If we go with 11, you get 2e equals 2e equals 4, and so you have the solution. Very, very odd that that keeps happening. Okay, there we go. And I'll close this. Keep thinking I turn everything off. So you get the solution here. You get 2e equals 4. I can write it out. 15 minus 2e equals 11, which you bring this over, you get 2e equals 4. So with integer solution, e equals 2. So we've got 2, 6. And then the last one is if f is 8, then k would equal 17 minus 2e. And because e goes from 0 to 9, this would go from a -1 to 17. Again, the only integer solution is from k equals 11, and when this is 17 minus 2e, then that means that we get a -6, so e is 3. So we have the solution 3 and 8. And so by exhaustion, that's the 4 solutions that we get for that situation. Okay, and that was our last problem. So, and I apologize for all the pausing I had to do. Just had stuff that I couldn't ignore. I apologize greatly. But we've got that last problem out of the way, and the next thing I'll post will be the solutions out of 5.1 for today's work. So I'll see you soon.